Hi, I'm Phil, and today I'm going to explore OpenCV on the Raspberry Pi 5. So let's go through this mind map and have a look at what I'm trying to achieve. So I want to have a look at computer vision. And I've already had a bit of experience with that, starting off with medical imaging, nuclear medicine, CT scanning, and advanced X-ray. At UTS, I had a look at a smart video camera for the chocolate factory. And for the transport management system, I was the project manager for the video system. And I took an interest in the infrastructure security of assets like the Sydney Harbour Bridge. And in STEM education, I've been looking at using cameras and AI technology to identify rubbish, to make sure that the students at Chatswood High School put their rubbish in the right bin. And more recently, I've been looking at the Mars rover and using a smart camera to identify a path with the least obstructions so it could move forward. So what I want to do is link photography, computers, maths, and software. And for that software, I'm going to use OpenCV on the Raspberry Pi 5 under Bookworm. I'll be using Python, and for machine learning, I'll be moving on to AI. So that'll be done later on. But I'll be using simple benchmarks and learning how to identify objects like handwriting and simple objects like cars, houses, people. When we go on, we're going to look at the installation. So all I am doing at the moment is using the Raspberry Pi. So 90% of the projects I'll be exploring will be using a Raspberry Pi, but I'll be extending that with the camera, the Raspberry Pi camera, and also I'll put on a hat like the Sense hat, and that'll convert the whole configuration to a camera. So I can use the joystick and push button on the Sense camera to take photos. And I've been looking at installing these on 5 Raspberry Pi cameras and had success with 4 of them so far. So if you want to install it, there's quite a number of methods because OpenCV is quite old now. It's actually about 24 years old. And if you do a Google search, you'll get many suggestions on how to install it on your Raspberry Pi camera. So after about 3 or 4 trials, I eventually came across a couple of the methods. So the best method was this one, where I was able to go through an installation and make sure that it was the latest version. So these are the processors. So everything in yellow here is a command line on the serial terminal. And I also imported successfully a number of the related Python libraries. Okay, so they're quite important if you want to do the more advanced projects. Okay, so that method, I was able to install it without establishing a virtual environment. But before I did that, I had a look at this process where I installed it again without a virtual environment, but some of the methods suggest you do that. Okay, so we might have a look at some of the photo processing. Some of the websites for OpenCV have obviously done their processing on very large images. So you might have to do a bit of image resizing. And you can do that with an additional program you can load onto your Raspberry Pi. Or alternatively, you can use OpenCV. There's a method there that will resize, and that would be quite useful. Also, I installed GIMP for the first time, and I was quite pleased with the operation of that. So while it's related, it's a manual process, whereas OpenCV is using Python and mathematical methods to alter your image. So the software, I eventually got OpenCV with no environment. I'm using Bookworm and the Python libraries. You can see the ones that I would like to install. And I will be using these benchmarks later on. Had a bit of success, although had a bit of trouble just doing the random project as a demonstration. But what really made a difference was this reference. So we might actually have a look at it. So I purchased this book, Mastering OpenCV with Python. And what's important about both the publications and the websites you choose, go for a more recent one, because I want to use a version which is the latest one of OpenCV, and this one's pretty close to it. There is a version that's been released since then, but I found that reference to be quite useful. I'll give you a few examples of these. So in the reference, I've been going through one of the chapters every day and testing some of the software. So we might have a look at some of that. So I'll just open up some of the topics. So in chapter 2, they start off very simple by reading and displaying an image in Python. So we might have a look at some of those. The other ones were regions of interest and manipulating a single pixel in an image and doing some very simple drawing like lines and rectangles. So let's go across to the Raspberry Pi. And I've got the Raspberry Pi here on a remote screen with a program called the NC. So what I'll do is I'll open up and we'll go to the reference. The reference comes with a website where you can download the program, so you don't have to type them all in yourself. So what we'll do is just open it up, go to chapter 2, and what we'll do is just have a look at reading some images. So we go to the simplest program possible, and I'm going to open that up on Thonny, and that's coming up now. So what you can see is the program in Python, where I'm importing the library CV2. I'm set up an image called dogs, and I want to show that, and I will destroy the image when I press a key. So I'm going to run that now. Okay, you can see it. Now, that illustrates one of the problems with using this book, because the image sizes are much bigger than the image size that I've got on the Raspberry Pi. So I'm going to have to do something about that. So we'll close that one down, and we'll look at perhaps extracting from a region of interest on the image. So you can see the program sizes are getting bigger, and you can run these fairly quickly. So here we are. We're going to identify a region of interest and put a label on that and show it on the screen. So the program's actually quite simple. So we'll run it now. Okay, so there we go. Another example of the image. There's the region of interest up here. And even though the image was quite large, it was able to show it on the screen. So we might do some drawings. We'll do some circles. We'll open this on Thonny. And here you can see that I'm got a canvas, and I've got 3 circles with different radii and different colors, and I'm going to draw those on the screen. So we might just move the program down so you can see it. There we go. So that's the whole program, getting a little bit bigger this time. So I'm not using an existing JPEG image. I'm going to construct those as objects. And there you go. I've got the image here. So there's the code and the result. And that's chapter 2, some of the examples that are on there. So here's chapter 3. And we go back to the mind map. Chapter 3, we're looking at things like structures, translation, rotation, resizing the image. So that resizing is quite an important one, and we'll have a look at an example of that. But you can do other things like flipping, shearing, cropping, and doing bit manipulations on the image, and having a look at the color spaces and the channels on an image. Now let's go across and have a look at some of those now. So we'll go back to VNC. We're on chapter 3. And what I've done, I've got the images for the examples are in the same directory. So the one that's the most important one is the resizing one. So we'll open our Python IDE. And here is a very simple example where we take an image, input image, we then resize it, and we're resizing it by 50%. That is in the X and the Y direction. And we're going to show both the original image and the resized image. Quite a good example, this one. And for many of the examples in the book, you need to use that resizing if you're using a Raspberry Pi. So let's run it and see how it works. Okay, so let's have a look at that resizing again. And what I've done was to modify to pick up an image which is actually in the directory. So we look at images. The one I'm interested in is cats. And this is what it looks like, the original image. And what we're going to do is go back to our Python program, and I'm going to do a couple of things. The first thing, I'm only going to resize it at both X and Y at 50% of the original image that we just saw. I'm going to run that program, and it's going to show both the original image with a label and the resized image. But just for interest, I'm going to also uncomment another resize and run that one. And you'll notice this one is actually changing the coordinate sizes of X and Y to 640 by 480. So let's run that one. And you can see it's distorted compared to the previous resized image. So there are 2 methods you can use here. Specifying the X and Y number of pixels, or directly with the percentage reduction. Okay, so that's chapter 2. See if there's anything else of interest in there. So we'll go back to our mind map. Things like cropping and the other ones are quite easy. This one here on image multiplication and subtraction, they're quite interesting. So we might actually look at one of the subtraction ones. So adding images to, we'll have a look at that one. So what we're going to do is we're going to resize the image. You might be able to use this sort of thing on your own photo work. Okay, so we'll go back to chapter 3. We'll have a look at the programs. What we're interested in is image addition. Here we've got image addition 2, and we're going to open that in Python. There's our program. So we've got 2 images, and we're going to resize the images so they fit on the screen. And this is an example where if you're on a Raspberry Pi, you have to resize it. And we're going to run that program. And here we are. We'll go back to the original. That's the result. And if you want to see those images, it's image 1 and 2 in chapter 3. So what we're doing, that's chapter 3, image 1. This is what image 1 looks like. And image 2. What we're doing is just combining those with simple addition. And this sort of illustrates what you can do with OpenCV and digital images and just simple mathematics like adding pixels together. And it's important when you do this that you resize this so they both are the same size. So we might just get rid of that. Now, one of the problems that I had is that some of the images just wouldn't fit. If you look at the size of this one, it's a really large image, and the Raspberry Pi can't access it. So we might move on and have a look at a couple more. So that's chapter 3, just a bit of a sample of what's in the book. Chapter 4, what we're doing there, we're looking at operations that are called erosion, dilation, opening and closing, and gradient, and a couple of the modifications of those, top hat and bottom hat. So what we might do is just have a look at, say, the gradient as an example. And the objective here is that we want to highlight the boundary of an object. So what we're going to do is go to the program. There's a path for it, and the result should look like this. We might compare that with the original. Go back to Python. We're on chapter 3. And what we're going to do is look at, let's see if we can get the name of the program again. There's image resizing. There's the addition, bitwise. Of course, what we've got to do there is select chapter 4, and we're looking for, we've got blurring, dilation. Let's see if we can find our Gaussian. Well, there we go. We've got it here. Morphological gradient, it's called. And this is a more advanced example of blurring in our image. So we'll open that up. And it's in our IDE. So what we're going to do is select the image. Let's see if we can find what the original image looks like. We are going to show it. When we run it, we should be able to see both. Okay, so what we're doing now is having a look at the morphological gradient, and we'll look at the image that we want to transform. So we go back to our image. There's chapter 4. And the images for that are right on the top. And we're looking at image. We'll open that up. So what we want to do is look at forming gradients, which is really going to be an outline of what we see here. So we'll run that, go back to our program, which is right down on the bottom. And we'll put that under Python. and it's already in our IDE, and we'll just run that. There we go. So you can see what we've done here. We've actually formed a border at the transient areas in our image. Okay, so we might just move on and have a look at some more and see if we can find those. Go back to our mind map. So that's chapter 4. And I've done chapter 5, histograms, chapter 6 with thresholding. And the last one I've done, I still have to read chapters 8 to 12. So in chapter 7 is the last chapter I've done. I'll just show you a couple of very simple examples there. We might do contour approximation, and the program is, the objective is to identify a boundary of an irregular object and overlay it with an image. So what the image will look like is this one here. So what we're going to do is identify the boundary of that. And the program's called contour approximation. So we'll go back to our, see if we can find our Raspberry Pi. Here's the last one that I've just been working on. It's chapter 7. Now, here we go. We need to find the name of our program. So we'll go back and get the name. Go back to the mind map, and it's called contour approximation. Go back to our Raspberry Pi. There we go. There's the program, contour approximation. We'll open that up on the IDE, and you can see the program here. We'll just open that up so you can see the whole program. And it's going to use box 1. And we'll have a look at that program. So it's on box 1. See if we can find the image. Where's our image? Here we go. There's our box. And what we whole goal is to identify the boundary of the object. So we'll close that, go back to our program, and you can see we're opening up box 1, and we're going to make a copy of it, and we'll show both of those together. So we'll run the program, and there you are. There's our program. That's the approximation on the first one and the second approximation. So our program is actually doing that twice. It's forming a grayscale and doing the maths on that using the arc length and the approximate polygram DP algorithms, then drawing the two images. And we'll go back to mind map, and we'll just conclude. So if you're interested in this, go to the references. See if we've got them down here. So OpenCV has a very good website. I recommend Q Engineering if you want to install OpenCV on the Raspberry Pi. And some of the issues are, it's best to do this on a system that has a SSD drive. Don't put it in a virtual environment, and get the latest one. You can always check the version of OpenCV to make sure you are using the latest version. And that's all from me for the time being.